Thank you. Okay. Kernel, I didn't introduce kernel-based method, okay, in support vector machine. But eventually, okay, that kernel idea, if you know SVM, okay, is extended to many different areas. And it's extended also graph data, okay, which is graph kernel, okay. So good thing is, graph kernel, what's difference even, just adjust matrix and graph kernel. So if anyone knows the kernel-based method, could you explain what's the advantage in machine learning data mining? It can explore, right? Any kind of nonlinear models. In real life, right? You will see, the difference between statistician and machine learning guys. Statistician, if you take linear regression, they assume certain model that follows linear model, right? Beta 0 plus, beta 1 exon, blah, blah. Machine learning guys, they do not assume any model. Okay, we don't know whether data follows linear model or nonlinear model. Okay, that's a good thing, okay, more realistic in my view. And the kernel, by exploring different kernels, we can find out appropriate nonlinear models. Okay, that's the beauty of kernel-based method. I'm going to explain the second part. That idea is extended to graph data. Okay, now graph data, right? Original data is adjacent matrix. If you use it only, for graph kernel, they use second order, some power of adjacent matrix. Actually, there are different graph kernels. So our idea is we see the effect in the graph kernel, not here matrix. So there's it. Oops. So there are some graph kernel of adjacent matrix. Von Neumann kernel is given this way. Exponential diffusion kernel. There are a few different kernels. So we find out the effect of removing nodes using the singular value decomposition in the graph kernel. So then there are some properties like here. Sungim, can you follow me?
Yes.
Rather than in original A matrix, we explore it in graph kernel. Then I have to mention the graph kernel actually. Let me see an example here. What's the advantage of graph kernel? Let me explain. Any two example here. Usually, let's see. Usually, if you use original adjacent matrix, influential node is they count direct citation. Can you follow me? This is direct citation, right? How many? Paper 4 is citing 2, 3, 4, 5, right? 5 direct citations. But also there are 4 indirect. Even indirect, we say second level. How about this? They have 5 direct citation, 0 indirect citation. How about this one, first one? How many? So there are maybe 5 direct, but there are many indirect citation, right? So which node do you think is more important? This one or this one? Which one, Sungim? Among there are 6 networks, right? They all have actually same the 5 direct citations. But graph one, they have many indirect citations. So when you measure inference of each node, we have to consider direct citation, indirect citation in different levels. Graph kernel, they can consider it. So I'll skip the details. So it's a good answer, Sungim?
maybe. It's a difficult thing.
Nice. Okay. Okay. What's the second question?
Second is the in calculation, is there vanishing gradient problem between those? I think it's similar. It's likely to sequential data. I think the relation between those.
Sequential data? What do you mean sequential data? Here.
The rusty nose has all information.
Left note, which figure you're talking about, for example?
Nose 9 has direct inference from 5, 6, 8, but nose 9 also has 1 indirect inference.
Okay. Node 9. Okay. Node 9, right, is citing actually, right, the paper 1. Also is citing paper 5, right?
Yeah.
But paper 5 is citing the paper 1. So what is your question?
제가 영어가 짧아서
Yeah. Okay.
한국말로 하자면
Yeah.
그 마지막에 노즈는
네.
5가 가진 그 만약 1에서 9로 지금 디렉트하게 가게 되지만 이게 없다라고 생각을 하면 이 5는 1, 그 앞에 있는 또 인디렉트한 페이퍼의 정보를 다 가지고 있기 때문에 만약 제 생각에는 웨이트를 백프로파 같은 거 하면은 이 그레디언트가 계속 2승, 3승 되다 보니까 사라져 버리니까요. 그래서 이제 노즈를 없애신 건 아닌가 이런 생각도 들었고 그런 문제가 이 시기에서 생기지 않았나 그런.
Okay, I see. Your problem is a little different. Okay, very good point. Okay, so okay, you made a good point. Let's see. Okay, she made a good point, but let's see the examples. Okay. Let me make one very small example. Okay. Let's see. Okay. This is on paper 1. Decided by usually, right? If the paper 1 is decided by paper 2 and 3, if there are more, this is called direct citation, right? Direct citation, we call it. If there are more direct citations, usually how do you think the paper is important or not important? It's important, right? Okay, more direct citations. Okay, here for another patent, let's say 5. It has 2 direct citations, right? But paper 6 is cited by some other 2 papers. Okay. Then between paper 1, paper 5, which one is more important? That's the questions we have. Okay. Minzu, how do you think? Which paper is more important? Paper 1 or paper 5?
I think 5 is more important than 1.
Why?
The 5 had more patents than 1.
Okay, they have indirect citation. Okay, let's see, 11. Let's assume even in direct citation, right? Indirect one, right? 1, 2. Let's see. Let me use different color. This indirect citation concept is very important. In scientometrics, they started to use our idea a lot. Okay. Here I skip lots of things. Okay. Level 1, indirect citation. Level 2, we defined indirect. This is direct one, right? Direct. Level 1, indirect. Here, level 2 indirect. Which one is the most important one? Direct one, level 1, or level 2 among three? Minsu. Direct citation, right? Is the most important, right? Wow. But we have to consider also level 1, level 2 indirect citations, okay? Level 1, more weight, more importance than level 2. But in huge citation network, actually, there are many levels of indirect citations, okay? So if you see kernel idea carefully, okay, here, this one is actually, this adjustment is only considered direct citations. This SQL actually is level 1 indirect citation. If you, we can prove it. This one is level 3, level 2 indirect citation. So as you can see, alpha is smaller than 1. Less weight here, okay? Of course, we have to optimize those alpha eventually, okay? So in this way, this graph kernel systematically consider indirect citations, okay, different levels to measure importance of each node. Okay, so for example, where is it? First example here. Here. Right, for example, right here, if you remove a little very specific example, okay? Remove this one, right? It's affecting only these two, right? Node. If you remove this on direct one, remove the node 5, it affects also direct node and many indirect nodes. That's why we call this node is very important one. If you consider only adjacent matrix, only these two may be affected. Okay. Any other questions? Okay. So this graph kernel is very interesting properties. Okay, you guys may study graph kernel. Okay, they systematically consider many indirect citations. Okay, so we propose many here, right? In graph also, how to measure similarity between two nodes is an important topic in graph problems. Okay, how to measure similarity between two nodes or two patents or two papers given citation networks. Okay, so we suggested some similarity measures. Okay, and many people use our measures nowadays. Okay, in biblio in the scientific matrix. Okay, very interesting idea. Questions? So now, okay, so based on our idea, we can measure importance of each node, right? So for our real life data, this is actually published work, okay, in a very good IEEE journal. Let's see. Okay, we reduce only 4,000 nodes, actually huge networks. We ranked in the citation patent citation network is information and security area. Okay, all patents in this area, we try to rank which patents is more important. Okay, only US patents. Then we studied some popular measures and our proposed, right? You can see their patent ID different ranking, right? Different ranking result. Right? So existing measure says this one is more important. Ours, this is the most important ones. Any questions here? If you're a reviewer, you have to ask some important questions here. Different result, right? What's the possible question? 정관. In machine learning data mining, all the time, you have to prove that yours is better than others, right? How can you prove different results? classification problems, right? They have accuracy, right? Here, ranking, right, of the patent. Which patent is more important? How do you know? your ranking is correct or not? Any idea? Actually, reviewers of the paper, a journal, ask us, how do you know yours is better than others? Interesting idea, but how do you know? Any opinion? If you cannot defend it, your paper will be rejected. Sangnim, you guys have some research experience, right? Different method, right? Give us, right? Different ranking result, right? They may say, oh, this patent is more important. Ours says another one is more important. How do you know which one is more important in reality? How to validate? Okay? Our question is, okay, how to validate? Okay, for example, okay, our method shows, okay, top 20 influential patents, okay. This patent, okay, number 1. Okay. But others says these two are the most important one. Ours says this is the most important one. Or a different result, right? But how do you know which one is more important, actually? Anyone has any idea? Any idea? Any idea? I want to check your fresh ideas. Any ideas you guys have? Any idea? No one? All the time, okay, when you develop some new ideas, okay, validating it, okay, why your method is better than others is very important in data mining and machine learning. You have to validate, right? So any idea, okay, you need some creativity to validate it, okay? Here, we do not have the result, okay? So question is, right? Question is how to validate that your results are better than other existing ones. Minsu, any idea? You're smart. No idea, right? 정관. 지원, any idea?
Sorry.
You can talk if you have any idea.
Can you validate if a patent is important based on if a lot of companies use it, giving, royalty, a fee?
Okay, John, okay, very similar idea. Okay, so important patent, right? We could collect, okay, number of technology transfer. Okay, some important patent, right? They pay money, okay, and then use it. We could find our record. So we thought if patent is very important one, they may have more technology transfers. We showed some correlation between the number of technology transfer and we look at correlation. John, you have good potential to be a good scholar.
Thank you.
And ranking result. Okay, we look at the correlation. Then ours shows very high correlation. Okay, compared to other methods. Okay, then the reviewers are happy. Okay, so we are actually the first first, we are the first team who validated, okay, actually, those ranking results. There are many ranking papers, okay, for patent, okay, we are the first time to validate, okay, the ranking, okay. So usually IEEE journals, they ask us to validate, okay. But it takes lots of time, okay, to find that kind of data. Very good point, okay. Okay. So now, similarity between two nodes in the networks. Okay. Given, right, patent citation network, right? How to measure these two papers or patents are similar? Of course, right? We can look at text data, right? For each paper or patent, right? But your question is, we look at only network structure, citation network structure. By looking at those structure, could you know, okay, any two nodes, how much they are similar? It's very important concept, okay? If you can know it, you can group the node or group the patent, many things you can do there. Make sense? Okay, so there are existing, okay, similarity measures, okay? Sometimes they use keywords, okay, using the text data, okay? Then we, okay, let me briefly introduce. Okay, so here cosine similarity, right? Pearson coefficient, Jaccard index, okay? So let me, these two are very popular ones. If you know this concept in graph mining, it will be useful. So let's say paper X is cited by paper I, right? There are two concepts, co-citation, co-citation, and bibliocoupling. Co-citation means, okay, paper I is citing X and Y simultaneously. Can you follow me? Co-citation. Paper I or patent, whatever, is citing both X and Y simultaneously. Okay. Now, for example, right, X and Y is cited by, right, paper I, right? But if it is cited together in different papers, it means what? Those two papers are similar or not similar? It means similar, right? If they are cited together in many different papers, it means they're very similar. That's the concept of co-citation. Okay, co-citation. Two patents or two papers are cited together by another patent. If there are many co-citations, it means they are very similar. Make sense? You guys? Okay, that's the co-citation concept. Another one. Paper X and Y, both X and Y are citing paper I.